Okay. So in the today's session, we are going to move to the further part of unit number 5 of theodolite traversing of surveying one subject. Okay. So in the previous session, we have seen the concepts of closing error. So for that, we were having the formula under root summation of latitude square plus summation of departure square in order to calculate the angular correction. Okay, that is tan theta, which was been given by the summation of departure divided by summation of latitude, where theta indicates the direction of closing error. Also, we have gone through what do you mean by latitude and what do you mean by departure. Okay, so the latitude is nothing but whatever the distance which has been measured parallel to the north-south direction, it is called as latitude, denoted by capital L, and formula for calculating the latitude is nothing but L cos theta, where L is nothing but the length of that side of the traverse and theta is nothing but that bearing. Whereas departure is nothing but correspondingly the distance which is measured just parallel to the east-west direction. Okay, that is called as departure, which is denoted by the letter capital D, and the formula in order to calculate the departure is L sin theta. So similarly here L is nothing but the length of that side of the traverse and theta is nothing but the bearing. Also we have gone through the how the conversion of correspondingly WCB to RB is to be done. Suppose the line of the traverse lies in between the angle 0 to 90 degree. The in order to convert the WCB, that is whole circle bearing, to radius bearing, first quadrant will be northeast, the angle will remain as it is, that is WCB. Where it is lying between second, that is southeast quadrant, so 180 minus whatever the angle you are going to do it, you will get the correspondingly RB. Suppose the line lies between the southwest quadrant. Okay, so whatever is the WCB is there, so WCB minus 180 will give us the respectively reduced bearing, and when the line lies between correspondingly northwest quadrant, okay, so 360 degree minus WCB that you have measured, you are going to do it. Okay, so now basically there are certain formulas in order to do the balancing of the said traverse. Okay, so before going to the problems, okay, write down the heading balancing of traverse. Okay, balancing of traverse. So we have seen that correspondingly the in order to do the balancing of a traverse in case of closed traverse, one formula we have seen that summation of northing should be equal to summation of southing, and that of summation of easting should be equal to summation of westing. Okay, that rule we have seen, that is dealing with our said theodolite traversing project. Okay, or said calculation. Okay, so I'll write down here. So it is required here. Summation of northing should be equal to summation of southing, and summation of easting should be equal to summation of westing. Summation of westing. Okay, or correspondingly summation of latitude should be equal to 0, and summation of departure should be equal to 0 for balancing of a traverse of a closed traverse. Okay, that is summation of latitude must be equal to 0 and that of departure should be equal to 0. In other words, as I told you, summation of northing must be equal to that of summation of southing, and that of summation of easting should come out to be sum of summation of wastings. So practically, when we go on calculating, there are certain errors that are supposed to be determined, and then by making use of the certain formulas that are, first is nothing but Bowditch rule. Bowditch rule, first one. Second one is the transit rule, and third one is the itself named as third rule. Okay, so these rules we are supposed to apply and go on calculating the correction for respective traverse. Okay, so we'll see one by one what is the Bowditch rule, then what is the transit rule, and third rule. Okay, so first one, Bowditch rule. Okay, first one, Bowditch rule. So what does the Bowditch rule tells us correspondingly? Just a minute, I'll make it here. Yes, yeah. So what does the Bowditch rule tells us that? So basically this Bowditch rule is mainly applicable most of the time. Okay, most commonly method used for traverse adjustment, that is in case of closed traverse, and correspondingly whatever the total error is there in the latitude or departure, that is distributed along the lengths of the traverse legs. So the formula for this is nothing but we are having correction to the latitude of any side should be equal to, formula is given as length. I'll put a bracket just a minute. I'll insert. Okay. I'll delete this. Just a minute. Cut. Paste. Okay. Correction to the latitude of any side is equal to, okay, length of that side divided by perimeter of traverse. So length of that side corresponding nothing but AB's length, and perimeter of traverse means correspondingly length, summation of all the sides into total error in latitude. This is the formula, first formula. Okay. Second formula, correction to the departure. Only changes we are going to apply the total error in departure. Got it? So this is nothing but the Bowditch rule. So correction to the latitude of any side is equal to length of that side divided by perimeter of traverse into total error in latitude, whereas correction to the departure of any side is equal to length of that side divided by perimeter of traverse into total error in departure. So this is the formula for Bowditch rule. Okay. Second rule is transit rule. Okay. Second one is the transit rule. Okay. So the formula for this also it is same, only slight change is that correspondingly you are going to apply the corresponding to the arithmetical sum of latitudes. Okay. Instead of perimeter of traverse, okay, you are going to calculate as per the latitude of that side. Okay. So we'll write down here first, correction to the latitude of any side is equal to, instead of length it will be latitude of that side divided by arithmetical sum of all sum of all latitudes into total error in latitude. Okay, so this is the formula. So instead of perimeter of traverse, only you are going to make use of arithmetical sum of latitudes, and correspondingly, instead of length of that side, you are going to make use of latitude of that side. Okay. Similarly, for departure, what will be the formula? Okay, change will be nothing but here, instead of latitude, it will be departure. Okay, so whenever we are going to solve the problem, in that case, you will understood it. Okay, departure of that side divided by arithmetical sum of all the departures into total error in departure. But these formulas you should know it whenever we are going to solve the numericals. Also, these formulas are required whenever we are going to deal with the said Gales-Travers tables. Okay, so basically, as we are going to make use of the Bowditch rule only, but the person who is going to deal with the Theodoret traversing, he should know each and every rule. And third one itself is third rule, as I told you, this is the most time consuming rule. Okay, so in that case, you are going to do the correction for each and every northing and correspondingly southing, easting, westing. Okay, so from the formulas only we'll get the idea. So correction to the northing of any side divided by northing of that side divided by sum of northings into, okay, here it will be again one half into one half into total error in latitude. So you are going to divide it half, because latitude is nothing but summation of northing and summation of southing. Okay, so the error of latitude should be half in this case. So you are going to apply half of the error. Okay, correction to then southing. Okay, so instead of northing, it will be here southing. Then instead of southing, northing, it will be here southing. Then again. Okay, so these are the formulas for latitude. Again, we are supposed to go deal with the departure. So there we are having easting and westing. Easting of that side divided by summation of easting and total error in now departure, because the easting and westing are dealing with departure. Okay, and finally last formula, that is correction to wasting. Okay, so here it is, sorry. Okay, wasting, here should be wasting. Okay, summation of wasting into one half of total error in departure. Okay, so these are the three rules which we required, that is Bowditch rule, transit rule, and third rule for solving these numericals. Okay,